Hello, 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 everybody, and welcome back. I hope you're all doing well. And you're ready to take a look at question number 4 on our 2019 Hypatia. So we got a light bulb and 2 written parts here. A. Suppose that C is a real number. Solve the following system of equations for x and y in terms of C. Okay, nice little simple solving systems of equations. There's lots of ways you can go about doing that. What have we got here? 3x plus 4y equals 10. 5x plus 6y equals c, I think is what they just had. Yeah. So we want to solve for x and y in terms of c. So I'm going to multiply this first equation by 5, and the second equation by 3. You'll see why in a moment. 15x plus 20y equals 50, and 15x plus 18y equals 3c. And the reason being, now I can subtract one equation from the other, and these x's will cancel out. So I'll be left with 2y is 50 minus 3c. So in terms of c, y must be 50 minus 3c over 2, or I guess you could say 25 minus 3 halves c. Now we could take this and plug it back in here to solve for x in terms of c. That's perfectly fine. Or we could do the exact same trick. Okay? Take the 6 here, multiply the first equation by 6, and the second equation by 4, and that'll get rid of the y's. So I'll have 18x plus 24y equals 60, and then we will have, what was it, 5? 5 times 4, so 20x plus 24y equals 4c. Subtract or, rearrange so the 20 is on top. Doesn't matter to me. Minus 2x is 60 minus 4c. So x, just divide both sides by 2. You'll get 30 minus 2c, but negative 2 will actually switch things around. So we'll say 2c minus 30. So x is 2c minus 30, and y is 25 minus 3 halves c. And if you want to, take those and plug them into the original expression. Okay? They'll cancel each other out in the first one, because 3 times 2 is 6, and 4 times 3 halves is 6 as well. And in the bottom equation, they'll leave you just with 1c. Because 5 times 2 is 10, and then 6 times 3 halves is going to be 9. So you're left with 1c. But, it's up to you whether or not you want to check. Remember, you only have 75 minutes to do this. It's a light bulb, so I'll just put a little box around that. Okay, but checking can often make sure you haven't made any arithmetic mistakes. All right, B part. Determine all integers d for which the system of equations has a solution where x and y are integers. Okay, now, if you know some linear algebra, if you know like matrices, you could probably approach this with matrices and matrix inverses and things like that. I mention this just because, eventually you're going to start learning those things, but it's not always known in high school. So let's actually continue with the approach we've been doing in part A. But we're now focusing on D in particular. Okay, and we want integer solutions. So, what can we do? Well, we've got x plus 2y equals 3, and then it was 4x plus, wrong one. 4x plus dy equals 6. Okay, multiply the first equation by 4, you'll get 4x plus 8y equals 12. Subtract, you'll get 8 minus dy equals 6. And so we would want y equals 6 divided by 8 minus d. So 8 minus d must be a factor of 6. Okay? Can we learn anything more? Well, we could do the same sort of setup, but get rid of the 8 and get rid of the 2 and the d. So multiply the first equation by d, you'll get dx plus 2dy equals 3d. This is going to have a lot more d's, but it might be helpful for us. And then we'll have 2 times the bottom equation, so that'll be 8x plus 2dy equals 12. So I'll have d minus 8x is 3d minus 12. That's 3d minus 4. So x is 3d minus 4 over d minus 8. And as long as this expression and this expression are integers, we'll be all set. Okay? I think focusing on this condition is probably going to be key. There's only so many things that divide 6, but remember, you can have negative numbers. So let's say 8 minus d. Minus 6, you could have minus 3, minus 2, minus 1. You could have 1, 2, 3, and 6, and that's it. Those are the only things that divide 6. And y has to be an integer. So if that's the case, what is going to be d? 14, 11, 10, 9, 7, 6, 5, 2. What's x and what's y? Actually, I think I'll do y first because I think it's a little easier. Y is 6 over 8 minus d. X is 3, d minus 4 over d minus 8. As long as I've copied that right. Yes. Okay, which I guess we could change around. Just multiply top and bottom by -1. So it's the same 8 minus d as before. So -1, -2, -3, -6, 6, 3, 2, 1. So this gives me my nice y values. And then the real test is x an integer. So d minus 4, or sorry, 8 minus d, because we just switched that around, didn't we? 4 minus d, 8 minus d. Actually, I think, let's get another column for 4 minus d, just so everything's nice and orderly. So just add 4 to whatever's over in this column. So minus, subtract 4. Minus 10, minus 7, minus 6, minus 5, minus 3, minus 2, minus 1, and then finally 2. Okay, and so we'll get -30 over -6. Well, that's 5. You'll get -21 over -3. That's 7. Looking good so far. -18 divided by -2. That's 9. -15 divided by -1. That's looking great. Might be that all of these work out. -9 divided by 1. X is -9, but they didn't say positive integers. They just said integers. -6 divided by 2. It's going to be -3. -3 divided by 3 is -1. And 8, and then 6 divided by 6 is just 1. So it looks like all of them worked. What did they want? They want the values of d, or how many values of d? Determine all integers d. Okay, all of these work. Every single one of them works. Kind of nifty. Okay, so d is 14, 11, 10, 9, 7, 6, 5, and I think it was a 2. Yep, 2. So that's it. Only those d values will work and give me integer solutions. Okay. So there we go. Well, now hold on for a second. If I multiply this equation by 4, I get this one. If I multiply this equation by 4, I get... Okay, no, yeah, I think we're fine. I was worried because if it was something like x plus 2y equals 3 and 2x plus dy equals 6, technically d could be 4 and you'd have an infinite number of solutions. Pick an x and you can find a y. And surely there must be some integer solutions there. I guess we did kind of make the assumption that d wasn't equal to 8, didn't we? Yeah, what if d equals 8? We got x plus 2y equals 3, 4x plus 8y equals 6. But multiply that first equation by 4, you'll get 4x plus 8y is 12. Impossible. Okay, good. Always got to worry about dividing by 0. Okay. So, B part all done. Let's take a look at C part. What do we got for C? There isn't a D. Yeah, I didn't think there was a D. Okay. Determine a positive integer k, so we just need a positive integer k, for which there are exactly 8 integers n, for which the system of equations, yikes, has a solution xy where x and y are integers. So again, we're going to have to worry about divisions and things like that. Okay, let's start copying this down in the notepad. 9n plus 6 x, what was the other x? Because I'm going to have to multiply these together. 6n plus 4. Oh, so these are both 3n plus 2 times something. We got something y minus 3n plus 2 y, and then something, I saw a k at the end there. 3n squared plus 2n. Okay, so the coefficient of y here and y here just differ by n. That's probably going to be useful. And then, what have we got on the other side? 3n squared plus 6n plus 3k plus 5, which they've put in brackets for some reason. Okay. And then minus n squared plus 2k, what was it, plus 3? I think it was a plus 3. 2k plus 2, sorry. Okay, well, let's start with the x's first. So if I multiply the bottom by 3 and the top by 2, 18n plus 12, 18n plus 12x, minus 6n plus 4y, plus 9n squared plus 6ny, 6n squared plus 12n plus 6k plus 10, minus 3n squared plus 6k plus... Oh, the k's are going to cancel each other out. So subtract that one from that one. We'll have a minus 9n squared, minus 6n, minus another 6n, minus 12n, minus 4y. Then we'll have 9n squared. Oh, this should be a 12n. Plus 12n, and then 10 minus 6 is plus 4. Oh, that's kind of nifty. So unless n satisfies this quadratic, which it may or may not, actually, 3 and a 2. Is this 3n plus 2 squared? Oh, it is. Cool. So, what are we going to have here? Oh, it's doing that thing again. So we're going to have minus 3n plus 2 squared. Y is equal to 3n plus 2 squared. N is an integer, I believe. Yeah. n is only going to be an integer. So 3n plus 2 is never 0 because n isn't minus 2/3. That's the only way to make that 0. So we can see y is going to be 3n plus 2 squared divided by negative 3n plus 2 squared. So y must be negative 1. Let's say regardless of k, x, or n. Y is always going to be negative 1 unless n were negative 2/3, and that's not something we're considering. So that changes things up a bit because now I've solved for y. So y is negative 1, so we'll have plus 3n plus 2 here. Now solving for, well, actually, we'll just have x is equal to some quadratic in n. But we'll still need x to be an integer. Y is at least guaranteed to be an integer. That's 3k plus 5. And I'm going to keep it in brackets just in case there was a reason they wanted me to keep it in brackets. Nah, actually, well, if we need it in brackets later, so be it. But what I can do, I can take that 5, subtract off 2, and make it a 3. And I can take the 6n, subtract off 3n, and make it a 3n. Okay, so there's y. We'll also have 6n plus 4x. And then it'll be y is minus 1, so we'll have minus 3n squared minus 2n. And that's minus n squared plus 2k plus 2. Oh, I think, yeah, this is gonna go swimmingly. So add the 2n to both sides. And add 3n to both sides. So really what we got, 3n plus 2 times x. So dividing the top by 3 or the bottom by 2, either way you get this expression, n squared plus n plus k plus 1. Okay. So there's x. X needs to be an integer. So then 3n plus 1 must divide n squared plus n plus k plus 1. So I don't know what k is, but should be able to get an n squared out of that. Well, if 3n plus 1 divides this, then 3n plus, 3n plus 2, then 3n plus 2 must divide 3 times this. Right? And then actually, that can happen exactly if, since n being an integer implies 3n plus 2 has no factor in common with 3. Right? 3n plus 2 leaves a remainder of 2 when you divide by 3. So, 3n plus 2 divides 3 times that expression there. Well, it has no factors in common with 3, so it must have all its factors in common with this bit. And as long as I've got that nice little explanation, I can write that now. 3n squared plus 3n plus 3k plus 3 is 3n plus 2 times n plus 3k plus 3. So that happens exactly if 3n plus 2 divides n plus 3k plus 3. But again, the same multiply by 3 trick tells me that I must divide 3n plus 9k plus 9. And now I can say, well, 3n plus 9k plus 9 is really 3n plus 2 times 1 plus 9k plus 7. So we get that x will be an integer if 3n plus 2 divides everything, and it's all a nice little chain reaction, if 3n plus 2 divides 9k plus 7. Okay. So we need a k. And so because I've got these nice if and only ifs or equality sign equivalency signs, I know that if I can get an n that solves this, x will be an integer. And if I can get an x that is an integer, the n must solve this. So we need a k, so 9k plus 7 has exactly 8 factors congruent to 2 mod 3, or that leave a remainder of 2 when you divide by 3. So now that becomes our challenge. So, what can we do? Remember, they have to be, n can be any integer. They didn't say positive, right? Got exactly 8 integers. K needs to be positive, but n doesn't. So 9k plus 7 obviously has no factors of 3. So its divisors are congruent to 1 or 2 mod 3. But if d is an integer and d divides 9k plus 7, and d is congruent to, say, 1 mod 3, minus d also is a factor of 9k plus 7. It's a negative factor, but we don't often consider those. But minus d is congruent to minus 1, which is the same as 2 mod 3. And this sort of works in reverse as well. So for every factor that is congruent to 2, you get a factor that's congruent to 1. Every factor that's congruent to 1, you get a factor that's congruent to 2. So we need half the factors of 9k plus 7 to be... So if we need 8 factors, we need 9k plus 7 to have 16 factors exactly. Okay, half of them will be negative, so we need 9k plus 7 to have 8 positive factors. Okay, and even if all those factors are congruent to 1, the negative ones will be congruent to 2 mod 3, and those will give me the ends that work. So we need 8 positive factors. How do you get 8 positive factors? Well, there's lots of ways. So for example, if I were to do something like 9k plus 7 is a prime times a different prime times another prime. If we look at prime factorizations, you can figure out how many positive factors you're going to have. You take your exponents, you add 1, and multiply them together. So in this case, 2 times 2 times 2, 3 2s for 3 different prime factors, and we'll be all set. That's not the only way to do it, because of course 8 could be, you could have p to the 7th, and then you add 1, you get 8 factors. I don't think this is going to be the easiest thing for me to work with, but that could work. Or we could have one prime that has 3 factors, and another prime that has 1, because 3 plus 1 is 4, times 1 plus 1 is 2, and you'll get 8 factors as well. So really the hunt is on for, I just need one k, right? I don't need a formula for all of them or anything. Determine a positive integer k. I mean, we could try and be a pain and make a really ridiculously large one that they'd have to get their calculators out to work for, but let's not make our lives harder in the pursuit of just having fun. P, Q, and R might be the easiest thing to do, or really any of these will work so long as you get 9k plus 7. Now, we're obviously not going to take primes that are congruent to 3, because there's only one of those. But let's see, if P is congruent to 1, so K, 9k plus 7 is congruent to 1 mod 3. So if all of them are congruent to 1 mod 3, their product is congruent to 1 mod 3, but is that congruent to 7? Let's do it this way. Let's say they're 1 mod 9, 1 mod 9, and we'll make one of them 7 mod 9. So, let's say let R equal 7. Obviously, that's congruent to 7 mod 9. We'll say Q is 19, because 18 plus 1 is a prime. And we'll make P, so 9, 18, 28 isn't 1, 37. 37 should do the trick. So 9k plus 7 is 7, times 19 times 37. I wonder if you could, if there's an absolute smallest one that'll work, but this should be fine. But I think I'm going to have to grab my calculator for that. Yeah, so 4921, subtract 7, divide by 9. K is 546, will do the trick. Is that the best one? I honestly couldn't tell you, but it works for me. Okay. I suppose 7 is congruent to minus 2, so could we do something like could we try, like P is 2, R is 17, Q is 19, because then that's 1 minus 1, 2, and that should be giving me minus 2. That wouldn't necessarily be bad. And that's a K of 71. So there's lots of different values that work. But at long last, I don't want to take my K value and now figure out the N values and then sub it back in, because it's been a lot of work. It's been a lot of work getting here. So I want to trust my formulations, my calculations, that everything sort of works right. That N is an integer, or X is an integer exactly when this happens. Which happens exactly when this happens. Exactly. And because of this little explanation that 3n plus 2 has no factors of 3 in it, that we're okay to just be multiplying by 3 and still having that equivalence there. Okay, but really any p, q, r of different primes, any p to the 7 of different primes, p to the 3, q to the 1 of different primes, I think those are the only ways you're going to make 8 positive factors, 16 factors in total, including the negative ones, and you need to have no factors of 3. So none of the primes can be 3, and that should do it. Okay, K is 71. I mean, that's much smaller than this one, but I think both of them are good. And I think, yeah, that's it for our paper. So there's your 2019 Hypatia all squared away. Feel free to browse around the channel for other Hypatias if you're interested. But I'm going to keep on doing math contests, and feel free to join me for another one in the future. Until then, take care and have a wonderful day.